This lesson is on polynomial long division. We will cover the review of division of a polynomial by a monomial, go over how to divide a polynomial by a polynomial, the ordering of polynomials, how to do long division with missing terms, and working backwards using long division. First, we're going to review division of a polynomial by a monomial. Here is a polynomial divided by the monomial 3. And what you should remember is you should divide each term within the bracket by the monomial outside the bracket. So in this case, you're dividing each term in the polynomial, in this case it's a trinomial, by the monomial 3, and then you would get the answer x squared plus 2x minus 3. I also have a more detailed video lesson on division of a polynomial by a monomial that I'll link here. Another example is if you are going to divide a polynomial by a monomial, where in this case you have several variables and exponents that you have to deal with. All you have to do is once again divide each term in the polynomial by the monomial, but you do have to remember to use your exponent laws when you are dividing. Exponent laws such as when you are dividing two of the same base, you have to subtract the exponent, and when you have a negative exponent, you have to change in the numerator or the denominator position to make it positive. So in this case, if I split my trinomial or my polynomial into 3, dividing each by 5x squared y, going through the exponent laws, you have 5 divided by 5, which is 3. Then you have x divided by x squared, which when you subtract gives you x to the negative 1 at the top, so we're going to leave it on the denominator. And then you're going to do y squared minus y by subtracting 2 minus 1, which gives you a 1 on the y. In my next fraction, I'm going to do 25 divided by 5, which is 5. I'm going to do x to the 3 divided by x to the 2 by subtracting my exponents. 3 minus 2 gives me 1. And then I still have a y in the denominator that I will leave in the denominator position. I do not bring that to the numerator position. It stays in the denominator position. And in the last fraction, 5 divided by 5 gives me 1. And then I leave my x squared and my y on the bottom. This here, 3y over x plus 5x over y plus 1 over x squared y, is my final answer. Now we're going to talk about how to divide a polynomial by a binomial using long division. In this case, if you are given a polynomial, it's a trinomial, and you are dividing it by x plus 7, this is different from when you are dividing by a polynomial by a monomial, because in this case now you have two terms, and you can't just split 2x over 2x squared over x plus 7, 11x over x plus 7 minus 21 over x plus 7. So we are going to do something called long division, and you may have done long division a long time ago when you were first learning how to divide, probably using some numbers that were either 2-digit or 3-digit long. We're going to use kind of the same method, but in this case we are going to be using the same method with variables, and of course there are some rules that we have to follow. First, I would suggest that you turn any kind of division problem into a long division problem so that you have this long division symbol. And you have to also remember that this trinomial in here is being divided by this binomial out here. We call this the dividend. So the dividend is the polynomial that is being divided. So we are dividing this polynomial by x plus 7. The next step is you have to ask yourself, how many times does the first term of the polynomial, in this case 2x squared, how many times can this be divided by the first term of the binomial? So, or in other way, you can also say, how many times does x go into 2x squared? And then when you know that answer, you're going to put it on top of the division symbol. In this case, I know that if I did 2x squared divided by x, I would get 2x. So that's one way of doing it. So that's kind of also you dividing. I have 2x going on the top, but then you have to remember, just like what you did when you do long division with just regular numbers, you do have to multiply these two together. And then when you multiply these two together, you get 2x times x, which is 2x squared, and then 2x plus 7, which gives you 14x. Now you should know that at this point, you should actually subtract what you have in this part of the division problem now. So you're going to be subtracting the 2x squared with the 2x squared and the 11x with the 14x. So you're also using adding and subtracting like terms in your brain as well. You do have to understand that I put brackets around the 2x squared plus the 14x. I'm going to say this throughout the lesson. You do have to put brackets around this binomial because you do have to remember to distribute the negative to both terms in the binomial. You'll see that if I subtract 2x squared with 2x squared, I obviously get 0. But then if I do 11x minus 14x, I get a negative 3x. Now you have to remember, and again, this is also just a common part of long division, numbers, variables, doesn't matter. You do have to bring down the next term of the polynomial. In this case, it's negative 21. You bring it down next to the remainder that you have here. So what it looks like is this. So I had my negative 3x just kind of down here, but then I had to remember, oh, I need to bring my negative 21 down to match with the negative 3x minus 21. So you'll see that it's kind of like a step-by-step systematic process, but it's nothing different if you've already done long division in the past. Now that you have brought down the 21, you have to once again now ask yourself, how many times the remainder, in this case it's the negative 3x, can be divided again in the first term of the binomial? How many times does x go into negative 3x? Or what is negative 3x divided by x? There's a whole bunch of different ways that you can do this. The answer is negative 3. So x goes into negative 3x negative 3 times. I'm going to put this on top like I just did, and then you have to multiply once again just this term with the binomial. So now I'm doing negative 3 times x plus 7. And again, you're going to be distributing that negative 3 to both the x and the 7. What that will give you is actually negative 3x minus 21. And then once again, you are going to subtract your remainders, we'll call them remainders, from one from the other. And you again need to remember to put brackets around your negative 3x minus 21 that you multiplied to remember to distribute that negative inside. So this will give you a remainder of 0 after you've subtracted them. So once again, do not forget to distribute the negative inside the brackets. Put brackets all the time just so that you don't forget. This means that the quotient, that's another word you need to know, the word quotient, which is the answer to our long division problem, is 2x minus 3, and we have no remainder. What this also means, if you are somebody who likes to check your work and see if everything is right, if you did 2x minus 3 times x plus 7, in this case that's binomial multiplication, also known as foiling, if you've used the FOIL method, you would get the polynomial 2x squared plus 11x minus 21, which is the dividend that we started with. Here are two examples that I'd like you to try on your own by pausing this video, and I will go over the solutions on the next slide. Starting with the first problem, I'm going to change it into a long division problem, remembering that your polynomial, or your, in this case, trinomial, is in the dividend and your binomial is on the other side. I asked myself, how many times does x go into 3x squared? It goes in 3x times. The other way that you could have decided to do this is you could do 3x squared divided by x, which gives you 3x. Once again, the next step is to multiply. So I multiply 3x by x, which gives me 3x squared, and then 3x times negative 2y, which is a negative 6xy. Now that I've written this down, our next step is to subtract. Remember your brackets. When I subtract, I get negative 5xy minus negative 6xy, which gives me a positive 1xy. And then you have to remember to bring down the next term of your polynomial, which is negative 2y squared. Your next step is to ask yourself, how many times does x go into xy, or how many times can I divide xy by x? In this case, it's just positive y times. So if I do y times x, I will get xy. That's something that you also need to understand, is you're trying to get, when you multiply, you're trying to get your first term to be identical to the remainder that is already there. And it is. I get xy minus, if I do y times negative 2y, I get negative 2y squared. My remainder is 0. Again, if you wanted to check your work, you can multiply the quotient by the binomial to get the polynomial dividend. So you could do 3x plus y times x minus 2y, and that should give you your dividend if you do binomial multiplication. In the second example that I've given you, once again, I decided that I wanted to convert this into a long division problem. I need to ask myself, how many times does x go into 2x squared? Or you could do 2x squared divided by x, which gives you 2x. Once you know that, you're going to multiply your 2x by x minus 3, which gives you 2x squared minus 6x. The next step is to subtract, adding brackets around your multiplication here, your answer to the multiplication, your product. And then once you subtract, you are going to get 13x, bring down the negative 4, so you get 13x minus 4. My next step is now to ask myself, how many times does x go into 13x minus 4? In this case, x goes into 13x 13 times. So I'm going to put my 13 on the top. I'm going to do 13 times x minus 3. That will give me 13x minus 39. Of course, you have to remember to put your brackets around the binomial that you have here, the product that you put down here, 13x minus 39. You're going to distribute your negative inside. You're going to get that the 13x's disappear because they are equal to 0 when they are subtracted, and then you're going to do negative 4 minus negative 39, which is going to give you a positive 35, which is probably the first time we've seen this, is that we have a remainder, and that's okay. You're allowed to have a remainder. The remainder is 35, so the answer would be 2x plus 13 with a remainder of 35. Again, if you wanted to check your work, because you're somebody who wants to do that, you can still multiply the quotient, 2x plus 13, by the binomial, x minus 3, but you would also, once you do the multiplication, because you have a remainder, you have to add 35 to the answer to your multiplication afterwards, and when you do that, you should get 2x squared plus 7x minus 4, which is your dividend up here. Now let's talk about ordering polynomials, especially when you're talking about doing long division of polynomials. In terms of doing long division of polynomials, it is actually very important that your polynomials must have its term in, quote, the correct order. Now, I do want to have a little bit of a disclaimer here. There are many different ways that you can order a polynomial. It really depends on the person, the situation, the teacher, the student, the situation of the math problem. It's whatever is easiest in terms of the course that you're in. Personally, here is a pretty good outline of how to order your polynomials correctly. First, you should always identify your exponents, like look at the exponents of the main variable in each term. And then I would go by arranging it by highest exponent first. So you place the term with the largest exponent first, and then you continue with the terms of decreasing exponents. Then you should look at handling multiple variables, because sometimes you're going to get a polynomial that has more than one variable in it. If 2 or more terms have the same highest exponents, you definitely have to use alphabetical order to decide which one comes first. And your constant term always comes last. And it comes last because we do think of it as like it's a variable. It has a variable, but the variable is raised to the power of 0 because anything to the power of 0 is 1. Just a little note though on the bottom, when a term has multiple variables, if you have like xy, xyz, the preference is given to the term that has the highest degree. Now, the word degree is maybe something that you have heard when you were introduced to algebra. The degree is basically the highest exponent in that term. And if you have more than one exponent, the degree is the sum of those two exponents of that term. So we'll look at some examples that might actually make this a little bit easier for you. So in the first example, I have 3x squared plus 7x minus 5x cubed plus 2. If I talk to you about things that I just mentioned on the last slide, we're looking at exponents, we're looking at putting things in alphabetical order, but we don't have to worry about that right now because we only have one letter, which is the letter x. So really we're looking at ordering it in terms of our highest exponents first. In this case, our highest exponents is an x to the 3. Then we have an x to the 2, then we have an x to the 1, and then we have our constant at the end. So the correct way of ordering this polynomial is by doing negative 5x cubed plus 3x squared plus 7x plus 2. So going back on why this is important in terms of long division, this needs to be the order of your dividend. Because if you remember, we are using our binomial to go term by term to say how many times does our binomial go inside this polynomial. And in order to do that, our polynomial needs to be in the correct order. If we look at a second example, I've decided to make it a little bit more tricky. I've given you more than one variable. You have to remember that there are certain things that you need to follow. Thing number one, you have to make sure that you understand which one has the highest degree. The ones with the highest degree are these ones here, because 2 plus 1 is 3, 2 plus 1 is 3, and then this one has a 3, and then you have a y that has a 1, and you have a constant at the end. The correct way of doing this, and this could be argued by many people, and that's fine, again, it depends. I prefer putting the 5x to the 3 here because it is its own variable with its own 3 as the exponent or the degree here. Some people might actually have said that the way that I wrote it up here is correct because we do have a degree of 3, we do have a degree of 3, and we do have a degree of 3, and some people might want to prioritize the two variables first. So again, it really depends on the situation, the person, the long division problem. It might be that you do a long division problem and you thought you ordered it right, and then you realize by doing it that you didn't, and you switch the order in the middle of doing your problem, and that's okay. In my next example here, we're sticking with one variable, which is the letter x, and I have here a 4 degree, a 3 degree, a 1 degree, and a constant. So to reorder this properly, you would just have 4x to the 4, 3x to the 3, our 2x comes after that, and then our constant comes at the end. In my last example, again, I'm going to give you a little bit more of a tricky one because I've given you multiple variables with multiple degrees. And if we go by degrees, so this first term has a degree of 5, this has a degree of 4, this has a degree of 5, and this also has a degree of 5. Talk about going in alphabetical order, though, by highest degree first. So if I'm going in alphabetical order and who has the highest exponent first, technically it's the negative 2x3. Y squared that has the highest exponent that comes first, and we're in alphabetical order. Then I move on to the 6x squared y cubed because, again, I have multiple variables, but I like the fact that these two here have an exponent on them. And then I put the 5xy to the 4 after that, and then I hook on my lowest degree, which is plus 4x to the 4. So just as an explanation, I just want you to remember that this has the highest degree. It is in alphabetical order, and I've put the largest exponent first. Again, highest degree, alphabetical order, largest exponent second, and then highest degree, alphabetical order, and since the second letter has the largest exponent, I put this one after the first two, and then I brought my 4x to the 4 at the end. Let's talk about polynomial division when you have a term that is missing, especially now that you understand ordering. With the example 4x to the 4 plus 3x to the 3 plus 2x plus 1, technically there is a term missing between the 3x cubed and the 2x. Usually, if this is like a really beautiful polynomial, you would have an x squared term between the 3x squared and the 2x. And what happens when we divide a polynomial by a binomial in our case, when you're missing a term? Here's what it looks like. You have the polynomial here and the binomial here. We're going to start doing long division again the same way that we were doing it in the last few slides. In my first case, my x goes into 4x to the 4, 4x to the 3 times. So if I multiply my 4x to the 3 by the binomial, I get 4x to the 4 minus 8x to the 3. Now I'm going to subtract, remember your brackets, remember you're distributing the negative. The 4x to the 4 becomes 0, and I'm left with 11x cubed, and then I bring down my 2x. Then I have to ask myself, how many times does x go into 11x cubed? It goes into 11x cubed, 11x squared times. So then I would multiply and I get 11x cubed minus 22x squared. I add my brackets and I start subtracting, and that's when you notice that there is a little bit of a problem. For the first time, we cannot subtract these two because they are not like terms. So we are stuck now in our long division problem because we are missing that x squared term. So this is what you have to do when you are missing a term. When a term is missing where we cannot subtract, you must manually include the missing term with a coefficient of 0. So what this means is I'm going to actually just place what should have been between the x cubed and the x by adding 0x squared. Why is it 0x squared? Well, I'm not changing anything about my polynomial by adding something 0x squared because anything plus 0 is itself, right? If we talk about identity elements of addition and subtraction, anything plus 0 or minus 0 is just itself. But to help me complete my long division problem, I need to have an x squared term here. So if I go back to where I was, I will actually, in this case, do the 4x to the 3, multiply everything, subtract everything, but instead of bringing down the 2x like I did in the last slide, I'm going to bring down this new 0x squared. Once I multiply my 4x cubed into this binomial, and I get my 11x squared. Once I multiply my 11x squared into my binomial, now I am able to subtract because I have two like terms, x squareds, and then I'm going to again put my negative, distribute inside, and now I get I get positive 22x squared, and now I bring down my 22x, and then I can continue the polynomial long division, ask myself how many times does x go into 22x squared, and then multiply and subtract and so on. And the next term is a 1, so everything is in the right order and everything that is needed is in the polynomial. Here are two examples with some missing terms that I would like you to try on your own. I encourage you to pause this video and I will go over the solutions on the next slide. So for the first problem, I just really wanted you to see that between the x cubed and the -1, we were missing two terms, which was 0x squared plus 0x. And then if you wanted to, we can go through the motions of doing long division, but I don't want to spend too much time on it. I did see that x goes into x cubed, x squared times. I did multiply. When I subtracted, I do 0x squared minus x squared, just gives me -x squared. Then I brought down my 0x again, and then I was able to continue with the long division properly because I had like terms. In the second example, there was a missing x cubed and x squared between the 3x to the 4 and the -12x. Once again, I'm not going to go over this in too much detail because at this point, the long division, as you can see here, is pretty repetitive. But I did want you to see that because I did have a 0x cubed, because I multiplied 3x cubed by x plus 1 to get my 3x to the 4 at the beginning, I'm able to now subtract my like terms. It is honestly very possible, as well as you're doing problems like this, that you might not even notice that there was a missing term until you did the multiplication and then you realize, uh-oh, I cannot subtract like -12x by 3x cubed because they're not like terms. And that's okay too, as long as you realize it though, and as long as you know that you keep this in the back of your minds that this could be a potential issue as you're doing long division. Now let's talk about working backwards with polynomial long division. Now that you know how to do polynomial long division, now that you also know how to do binomial multiplication or foiling, you might be asked to find a polynomial given the quotient. So I'll give you the answer and its remainder, if anything, and then I would ask you to find one of the polynomials in long division problems. So again, we're basically working backwards. And one thing that you need to understand is when you're working backwards with something like division or you're working backwards with something like multiplication, you always have to ask yourself, what is the opposite of division? What is the opposite of the operation that I'm doing? So you might have also guessed that in this case, to do the opposite or to go backwards, you're going to have to do some multiplication. Now, I've also said to you in a few times in this video, just because I knew where we were getting at, is if you wanted to check your work, you always could just multiply the answer you got by that binomial to get the polynomial inside the long division, or the dividend as we called it. Here's how you would work backwards without a remainder. Dividing a polynomial by x plus 7 results in the quotient 2x minus 3. Find the polynomial. So you're finding the dividend. You're finding that big polynomial. And you're given the answer and you're given the binomial that is being divided by. So all you have to do in this case is just multiply the binomials. Again, you're doing binomial multiplication, and if you're using the foiling method, you can do it here, obviously. So you get 2x squared minus 3x was 14x minus 21, which is 2x squared plus 11x minus 21. And if you remember, or go back a few slides, this was actually one of the answers that I gave you, I believe, in the very first slide. So this is what we did. 2x squared plus 11x minus 21 divided by x plus 7, and we got 2x minus 3. This is us now working backwards. If I gave you the answer and I gave you the binomial, multiply them together to get the dividend. What happens if you have a remainder? Now, if you remember a few slides ago, I said to you, if you wanted to check your work with a remainder, you just had to multiply the binomial by the quotient, but then remember to add the remainder at the end. And that's what we're going to be doing right now. Here's an example. Dividing a polynomial by x minus 3 results in the quotient 2x plus 13 with a remainder of 35. Find this polynomial. So same thing, you're going to multiply the binomials, but then at the end, you're going to add the remainder. Doing this looks like this. So you're going to do x minus 3. So again, this is the x minus 3 binomial at times the 2x plus 13 quotient. And when you FOIL these out, or when you multiply this by doing binomial multiplication, you get 2x squared plus 7x minus 39. But then you have to remember to add the 35. It's the remainder. You're adding the remainder at the end. And then the answer you get is 2x squared plus 7x minus 4. And again, if you remember, this was a question I gave you a few slides ago. We did 2x squared plus 7x minus 4 divided by x minus 3. And the answer was 2x squared plus 13 with a remainder of 35. So I just need you to understand also that while these examples had two binomials, it's possible that you might be given other polynomials that you will have to multiply together. You're doing polynomial multiplication, and that's okay too, but it's often in this case, I'm just going to stick with binomials by binomials, dividing long division with just binomials. And that is the end of my lesson on polynomial long division. Thanks for listening.